So completing the square is when you are essentially going from standard form to vertex form. And the reason why you do that is because it's easier to graph that way, and also it's easier to solve by square roots as opposed to either doing the quadratic formula or factoring. Sometimes factoring is easier, but completing the square will also be helpful in the second semester when we start talking about conic sections, which is really fun. So I'm excited for you guys about that. So vertex form looks like this. Anytime you have vertex form, you solve by square roots. So we're actually going to take an equation that's in standard form. We're going to put it in vertex by completing the square. Then we're going to solve by square roots. So this unit, we're kind of trying to combine everything that we know. The a value must be equal to 1 to complete the square. If not, then you must divide both sides by the a value. So we're going to see a few examples in which you have an a value that is not 1, and then you're going to have to divide everything by that a value. So for completing the square, I have some steps right here. So these are the steps that you'll abide by. The first one is you collect your variable terms on one side and you move your constants to the other side. So I'm going to rewrite this equation as x squared minus 6x equals 5. You can do step 1 and 2 first. You can kind of combine those if you want. In this case, we don't have, like, our a value is equal to 1, so I don't need to divide anything. If I did, then I would need to divide everything by that a value. The second thing you want to do is you want to write your equation with a blank. So I have x squared minus 6x plus blank equals 5 plus blank. And so, yes, it's always going to be plus. That is a good question. These will always be plus. And so what you are trying to do, like what the goal is you're wanting to write the stuff on the left to be a factor, or you're wanting to essentially factor it so that it becomes a perfect square. And so the way that you do that is you're going to add b over 2 squared to both sides. So what I mean by b is my middle term. I'm going to take my 6, or my negative 6. I'm going to half it. So if b equals negative 6, b over 2 equals negative 3, and b over 2 squared equals 9. And you don't have to write out all of these three things every time. I'm just doing it to show you. But you're going to get really fast at it, and you're going to be able to do it all in your head. But essentially, you take your middle term, you half it, and you square it. So 3 squared is 9. So I'm going to add 9, and I'm going to add 9. And so what that does, when you do that, if I were to factor this, it becomes x minus 3 squared. Does everyone see how I factored that? It's becoming a perfect square. So if I actually wrote out x minus 3, I would end up getting x squared minus 6x plus 9. I would get back to where I started. So what you're doing is you're trying to find a value that goes in this slot that creates a perfect square on the left so that you can eventually put it into vertex form. So the value that goes in your little blank right here is always b over 2 squared. The value that goes right here is always b over 2. It's always half. But if you don't want to memorize all of that, then just think about, how do I factor this? So I'm left with x minus 3 squared equals 5 plus 9 is 14. Then I'm going to ask you usually to take it a step further, and I'm going to ask you to solve by square roots. So if I were to solve by square roots, then, or I'm going to ask you two things actually. I'm going to ask you to put it in vertex form, and then I'm going to say solve by square roots. So if I said, like, what is the vertex form of this equation? I would want to move the constant back over, and it would be x minus 3 squared minus 14 equals 0. So that would be my vertex form. Then if I ask you to solve, I would take the square root of both sides. So x minus 3 equals the square root of 14. Is there anything in the square root of 14? No. No. Then I'm going to add 3. So x equals 3 plus or minus the square root of 14. And so that would be, those would be my two roots, like if I were solving. Those would be my x-intercepts, or where the quadratic form or the quadratic function crosses the x-axis at 3 plus square root of 14 and 3 minus square root of 14. So these would be the two things I would ask you to solve. So first step here, I'm going to move my constant to the other side. If you want to go ahead and put your blanks there and all in one step, you definitely could. So if I wanted to just go ahead and do this in one step, I could. You guys are going to get to where you can do this in your head. You don't have to think, it doesn't take very long once you get the hang of it. So what goes in the blank, I take my middle term, which is negative 8. I'm going to half it, and then I'm going to square it. So negative 8 divided by 2 is negative 4. Then I'm going to square negative 4, it becomes 16. So I put 16 in both slots. Then I'm going to factor this. It's going to be x minus 4 squared equals 25. Then if I'm putting it in vertex form, x minus 4 squared minus 25 equals 0. If I were solving it, then I would square root both sides. So x minus 4 equals plus or minus 5. X equals 4 plus or minus 5. X equals 4 minus 5, which is negative 1, and 4 plus 5, which is 9.
Do you want us to write that as our answer on the test?
The directions would specify what I would ask you. So I would say find the vertex form and solve by square roots. So I would want two answers. I'd be looking for two things. Okay, I want you to try number 2. Okay, one thing to mention as well is when you're factoring, notice the signs. Look at the signs. Remember that your sign inside the parentheses, or when you factor, is based on your middle term, because you're always adding the third term. So I'm always adding my b over 2 squared. So that means that my signs will always be the same. And when your signs are the same, you always refer back to the middle term. If it's a minus, like a minus 8, then it's x minus 4. If it's minus 12, x minus 6. If it's plus 6, it's x plus 3. So make sure that when you are factoring it, you refer to the middle term, and that determines whether it's a plus or a minus inside when you're factoring it. Okay, any questions about these 4? If you didn't get it finished, then I encourage you to go back and kind of rework them. So let's go to the next page and look at when your A value is not necessarily 1, and what do you do in that situation. So I'm going to go ahead and let's look at number 6, because I'm pretty confident that you guys can do number 5. But if we look at number 6, so I have the first step that I'm going to do is I'm going to move the number over. So I'm going to say that this equals 0. If you have like g of x or f of x or something, set it equal to 0 first. So I'm going to rewrite this as 3x squared minus 18x equals 4. So I moved that over. Then I'm going to pull out the a value, or I'm going to pull out a 3. And you're not pulling out the greatest common factor. You are literally taking out the number that is your a value. And in this case, it is my greatest common factor. But you're always pulling out whatever my a value is. So I'm going to take out a 3. And I'm left with x squared minus 6x equals 4. Now I could turn this into one step and write my little blank, but I'm just going to show it as 2. So plus blank equals 4 plus blank. Now I'm going to take my a value, my b value, I'm going to half it, and then I'm going to square it. So what number goes in the blank on the left? 9. Here is where it gets tricky. In the right blank, you do not put 9 there. You put 3 times 9, which is 27. So that is what is different. So you put your a value times whatever goes in the blank. So when your a value is not 1, whatever number goes in the blank, you're going to take your a value and multiply it by it. So these numbers will not match up whenever your a value is not 1. Then I'm going to factor it. So 3x minus 3 squared equals 31. If I want to put it in vertex form, I move it back over. And then if I want to solve it, then I'm going to divide each side by 3. So x minus 3 squared equals 31 over 3. Square root it. How do I simplify this right here? What do I need to do? Multiply it by the square root of 3. So this is kind of combining the 6.2 stuff. Plus or minus. I need to multiply the top and the bottom. So when you multiply the top and the bottom by square root of 3, remember, you combine the two numbers, you multiply the two numbers on the numerator. So 31 times 3 is 93. There is no way to simplify that any further. I don't think. Is there? No, I don't think so. Because 9 does not go into it. So I'm going to leave it as the square root of 93 on the top, and then square root of 3 times square root of 3 just becomes 3 on the denominator. So vertex form looks like this. Solving looks like this. Okay, I want you to try number 7. Okay, so for this one, first step, setting it equal to 0. Then I move the 4 over, so I'm going to rewrite this where all my variables are on the left, number on the right. So negative 2x squared minus 16x equals negative 4. Then you always, if you have an a value that is not equal to 1, you pull that out. So I pulled out a negative 2, and that left me with x squared. When I pull out a negative 2 from the middle term, it leaves me with plus 8, and then plus blank, plus blank. I'm going to half 8, I'm going to square it, so 4 squared, I put 16 here. And why did I put negative 32 here? What did I have to do? Yeah, so I had to take the negative 2 and multiply it in order to put my right blank. I had to take negative 2 times 16. That gave me minus 32 on the right blank. Then I factor this, so it becomes x plus 4 squared. Do not forget to keep your negative 2 in the front. Then I combine negative 4 and negative 32 becomes negative 36 on the right. My vertex form, I'm going to move the negative 36 over to the left side, set it equal to 0. When I'm solving, I'm going to do PEMDAS backwards, so I divide both sides by negative 2, and that leaves me with x plus 4 squared equals 18. Take the square root of 8. When you are simplifying the square root of 18, you can pull out the 9, the perfect square 9. So it's 3 root 2, and then you subtract the 4. So negative 4 plus or minus 3 root 2.